So at this point, we'll talk about the fact that there are actually two different branches or portions or almost halves of statistics that we'll be getting into this semester. The first side of statistics is what we call descriptive statistics. And it's kind of the branch or the side of statistics that involves organizing, summarizing, and displaying of data. And this will be primarily covered in, well, it looks like I have a small typo here, but Chapter 1 and Chapter 2. These will be the main spots where we cover this. Now you can see some examples of what a descriptive statistic looks like. Notice, all of these statements here are only meant to just kind of state the facts of a situation. So I might say, Kyle's free throw percentage was 0.610, 61%. The best grade on the first exam in this math class last semester was 100%, right? I'm just stating a fact. The average lifespan for people of all races is 81.1 years, right? I'm just stating the information. That's what descriptive statistics is all about. The more interesting side of statistics is the inferential side. We'll spend most of our semester on this inferential side, but it's the branch of statistics that involves using our small sample to actually reach a conclusion about the population. And of course, one of the basic tools that we'll see this semester to help us make that distinction, or to help us make those conclusions, is probability. So probability is actually going to be studied for us in chapters, I believe it is numbers 3 through 6. So those numbers are a little bit off. And then actually in it's going to be chapters 7 through 11. We're going to talk about inferential statistics and how we can use that stuff to reach these big conclusions. So notice some examples of inferential statistics are listed below, and all of these, you'll note, are using a small sample to reach a conclusion about a population. So I could say something like, using the percentage of defective gadgets that occur in a sample, and I use those to estimate the percentage of defective gadgets in an entire shipment. So I have a large entire shipment, that's like my population, and I use something that I know about the sample to make a guess as to what's going to be happening with the population. Here's another one. MSNBC uses a small sample of polled voters to project who will win an election. Right? That happens all the time. You flip on the news, if there's an election upcoming, they're always going to go ahead and throw up poll numbers, right? Showing you kind of who they think is in the lead at the present time. Well, they definitely didn't ask everybody. They only asked a sample, right? You know they didn't ask everybody because they probably didn't ask you. So we know that with this small sample, we can see the news organization is attempting to make a prediction. A car manufacturer uses the safety tests on 30 cars to estimate the safety of all cars, at least of a particular make and model, right? I mean, how do they get, like you see these commercials where you say, this car's got a 5-star safety rating. How do they know that? Did they actually crash that car? Well, no, clearly not. I mean, that's a really poor business strategy. You don't want to crash every car. But maybe you can, do some safety tests on 30 of the cars, do some crash tests on a couple of them, and then hopefully be able to draw some conclusions about what's going to be happening with all the cars of this type. So these two branches of statistics we'll see throughout the semester. Notice that in our simulation, we kind of did a mixture of both of these. We stated what a simulation showed us, that was being descriptive, but then we also made an inference from that. We said, based on the data that I'm seeing, I'm going to make this conclusion. Now, if we want to make conclusions in a study, we're also going to need these other two definitions down below, what we call a statistic and a parameter. Now, these are oftentimes spots within the first chapter that some students tend to feel a little bit hazy. And this often tends to be a very missed question on the first exam, but it's a really easy idea if you try to drill down into what it's actually talking about. Notice here that a statistic is a numerical description of a sample. So it's a number that describes something about a sample. I always remember that those go together because statistic starts with an S, just like sample does. Parameter is just some numerical description of a population characteristic. Well, that is easy to remember because it goes with a P. Now, to try to help understand what we mean by this, we can think about all sorts of different scenarios and what we want to actually know about the things in that scenario. So statistics and parameters are often going to be kind of related to a what question, like what is it that I want to know about my population or about my sample? What is it? And oftentimes, since we use what we know about a sample to understand what we believe is going to happen in a population, these answers to these questions are going to very often or very likely be the same thing. In fact, they will pretty much always be the same thing. Take a look down at example number 3. I could ask what would be the statistic and the parameter in the scenario for example 1. If we were interested in studying the percentage of items that ended up colored red. Okay. So notice here that this portion at the back, what we are interested in, is going to help us understand what we want to know about the population and what we want to know about the sample. So if I wanted to know the percentage of items that were colored red, I wanted to know the percentage of items that were colored red, then the statistic would be the percentage of the selected 16 chips that were colored red. Notice I'm writing that as a sentence. This would be the number that I was looking for. Whatever this mystery percentage is, that is the statistic, right? It's exactly what I said up above. It's what I'm looking for. Now, fortunately, with the statistic, it's actually super easy to often find that value. Because notice here, we found that 15 out of 16 of the chips were actually red. And so if someone wanted to know, well, what actually is that percentage, you could go to the calculator, type this in. I think you get back something like 0.9, maybe like 375, right? Or a 93.75%. Right? So I actually have this value here, and that's easy to find, right? Because I have the sample, I can see the results. Now, when I want to find a parameter, again, that's going to be, in the same scenario, what am I interested in knowing about the population? Well, notice how similar my answer is going to be to what I have above. What I want to know about the population is the percentage of the 100,000 chips, that was all the chips in the bin, that were colored red. Notice, the sentences are near identical. The only thing that's different is that in the statistic sentence, I talk about the 16 chips. I talk about the sample because it's a statistic. And when I talk about the population, that means I'm dealing with the parameter. Now notice that this value is not easy to find because I don't know how many of the chips were actually red. I would never know that unless I dumped out all 100,000 chips and calculated them. So while I will have the value for a statistic, I will almost never have a value for the parameter. I'll be able to describe it in words, but I don't know its final result. That's why I state up here that in real life, population parameters are very rarely known. And therefore, much of statistics involves obtaining a sample statistic or sample statistics and trying to ultimately say that if I have this blue number, can I try to predict what I think that red number would be? Okay, well, in the next video, we'll see how we can kind of tie all of the ideas that we've discussed so far in this section together in kind of one summary example.